Hello everyone, this is Akanksha of USN 92, belongs to Bhaskara section, studying in Sri Venkateshwara College of Engineering. Today I am going to explain about the topic transition probability matrix. So, what is transition probability matrix? A transition probability matrix is a mathematical tool used to model the probabilities of transitioning from one state to another state in a system over time. So, the transition probability matrix are used in various fields such as finance, economics, biology, and engineering to analyze and predict the behavior of a system. The matrix is typically represented in a square matrix format where each element denotes the probability of transitioning from one state to another state. So, what are the elements of a transition probability matrix? The elements of a transition probability matrix are non-negative values that sum up to one along each row. Each row in the matrix represents the probabilities of transitioning from the current state to all possible future states. The diagonal elements of the matrix represent the probability of staying in the same state. So, what are the properties of transition probability matrix? The sum of probabilities in each row of the matrix is always equals to 1. The matrix in stochastic, meaning that all elements are non-negative. The matrix can be used to calculate the probability of transitioning through multiple states in a system over a specified number of time steps. So, how to calculate the future transition probabilities? Try to calculate the probabilities of reaching a future state. The transition probability matrix is multiplied by the current state vector. Then the resulting vector represents the probabilities of being in each state in the next time step. This process can be repeated iteratively to predict the state probabilities over multiple time steps. So, what are Markov chains and transition probability matrix? Transition probability matrices are commonly used in the context of Markov chains, which are stochastic processes that transition between states based on the probabilities. So, what are the Markov chains? Markov chains rely on the transition probability matrix to model the dynamics of state transitions over time. The matrix determines the evolution of the Markov chain and helps predict future states based on the current state. So the applications in finance, that means how the transition probability matrix used in the finance state. Transition probability matrices are used in finance to model the credit risk of financial instruments or borrowers. By analyzing historical data, financial institutions can construct a matrix that predicts the likelihood of a borrower transitioning from one credit rating to another. This information helps assess credit risk and make informed decisions about lending and investment. Then, how the transition probability matrix is used in biology. In biology, transition probability matrices are used to model the evolution of biological sequences such as DNA or protein sequences. By analyzing the probabilities of specific mutations or substitutions, researchers can infer evolutionary relationships and study the genetic diversity within populations. These matrices provide insights into the dynamics of genetics changes over time. So, how the transition probability matrix is used in engineering? In engineering, transition probability matrices are used in reliability analysis to model the failure and repair processes of systems. By qualifying the probabilities of system states, for example, functioning, failed, under repair, etc., engineers can access the reliability and availability of complex systems. This information is crucial for optimizing maintenance strategies and improving overall system performance. So, what are the challenges and limitations of transition probability matrix? One challenge of using transition probability matrices is the assumption of stationarity, which may not hold true in dynamic systems. The accuracy of predictions relies on the quality of input data and the appropriateness of the transition model. Large matrices with numerous states can lead to computational complexity and require efficient algorithms for analysis. So let's come to conclusion part. The transition probability matrices are powerful tools for modeling and analyzing the dynamics of systems that transition between states. From finance to biology to engineering, these matrices enable researchers and practitioners to make informed decisions and predictions based on probabilistic transitions. Understanding the probabilities, properties, applications, and limitations of transition probability matrices is essential for leveraging their potential in various fields. So this is about the transition probability matrix and Markov chains and how the transition probability matrix is used in various fields. Thank you everyone.